Hi guys, my name is Udit Garg. I'm presenting C19. This project is developed in collaboration with University of Oxford Machine Learning Group, University of Maryland, and University of Zurich. So we have Dr. Jack and Dr. Tom from University of Oxford, Dr. Atul from University of Maryland, and Dr. Zhao from Zurich University. As you will see, and you must have noticed, there are a number of contact tracing solutions coming up from both public and private partnerships. Our objective is to enable collaboration between all different stakeholders so that they can use the power of combined data sets. Here's a list of existing contact tracing applications that are out there, both by the state and central government. And there are a number of private initiatives also, which use both Bluetooth, geotagging, self-reporting, etc. For any of these contact tracing or self-reporting initiatives to be successful, there are two critical success factors that are required. That is A, very high user adoption, and second, a lead time required for these data collection sources to build an empirical data of at least 5 to 7 days. Considering the size of India and the problem is catered to the masses, there are a number of challenges, including only 27% of India has smartphone access. Therefore, a number of apps cannot be used. Segregated data collection, privacy concerns of people due to state surveillance, etc. All of these lead to long lead times. Therefore, the only viable solution that we can see is A, to enable alternate data collection sources, and also to enable them in a manner that they can interact with each other without facing the issues of privacy of A, the patients, and B, the users. Number of stakeholders could be mobile applications, which are already collecting user data, self-reporting applications, contact tracing applications, etc. The solution that we have come up with is a multi-party or double-blind computation communication protocol. What it simply does is it allows two parties with different data sets to interact with each other, run an analysis without actually sharing the underlying data with each other. I'll quickly walk you through a worked example. Let's say the government wants to identify all the people who have crossed paths with a patient, Mr. X of COVID-19, in the past 14 days. The government has limited location data of that patient. Whereas there are a number of applications, let's say hypothetically, PhonePe is collecting user location data for the purpose of its own application. And they have access to past 14 days of data, whereas government will take next 7 to 10 days, a lead time to generate that data. So how MPC would work is a key generation unit party, a third trusted party, can issue correlated encryption keys to both the parties without actually seeing the underlying data. Both the parties can encrypt the data sets. Beyond this point, no third party is required in the process. Now, the key point is these encryption keys are structured in such a manner they're correlated, thereby when the two data sets interact with each other, the corresponding encryption pads are cancelled out, thereby leaving you with just the final output of results. The results will be a list of mobile numbers for, say, in this example, who were in contact with Mr. X in the past 14 days. So thereby allowing government and private company both to leverage available data sources to do a simple task such as contact tracing in a short period of time, without the private company actually sharing the underlying data set of its users, or the government actually having to disclose the information of any COVID-19 patient. Both are very serious privacy concerns in general use case. So this is exactly how MPC would work. There could be another question around how would the output actually ensure privacy. So what the algorithm does is just basically gives the binary result, that is whether the person was in the location or not, thereby avoiding, avoiding any triangulation possible using distances that a number of other algorithms do. There are a number of MPC solutions available in the market. However, they're very computation intensive, therefore require a lot of processing power and time. What the research group here has been able to do is shorten that and make it practicable and specific for contact tracing, therefore easily deployable. I'll give you a quick update on the status. We have an MVP running, which is highly scalable. A detailed white paper in collaboration with research group University Oxford, Maryland will be public in next few days. What we want from government and India Inc. is to adopt the solution, consider this as a possible solution to make their useful data sets available for each other. And secondly, if this goes to scale, help us with implementing it by giving us support of infrastructure. We do not plan to charge or have no intentions of charging for this communication protocol from any party, as this is a purely humanitarian cause. That's it from my side. Thanks.
Thanks, Udit. I have one question from Akanksha Singh, who's asking, is it limited to 2 databases or can several databases interact with each other?
Several databases can interact with each other. Multi-party computation is a very known protocol. However, the only challenge is it is very slow and compute intensive. This approach makes it faster and practicable and deployable instantly.
Okay, thank you. Thanks, Udit. Manish Paul, you are next.
So sorry,
Yeah.
one point I want to make. We are open to sharing any further detailed information, specifications, or any to satisfy any concerns that any party may have in order to adopt the solution. Thank you.
Fantastic. Thank you.